Hi, welcome back to lesson Computer Science 20 with Data Structures 1. This is lesson 9, two-dimensional arrays. So last lesson we went over what an array is and how to declare it and fill it. We also went over an array list as well as how to declare as well as fill it, and we went over the differences between the two. Take a minute right now and think about what the difference is between an array and array list. Pause the video if that helps you. Anyway, the difference between an array and array list is that an array is a fixed size. You cannot increase the size or decrease the size after you've declared it. An array list is an indefinite size. You can repeatedly add to it. A major difference between that is rather than adding into the specific places of the specific positions for the elements in the array, it adds to the end of it. So you use the .add method. Another difference between the arrays and the array lists is if you want to access an element in array, you use the array name and then the indexing value syntax, whereas in array list you use the array name .get method, and then in the get method you put the position, you put the element's position in there, and it'll access it that way. All right, so hopefully you got those differences, or at least one of them. If not, please go back to lesson 8, arrays and array lists, and we're going to move forward now. So we learned about matrices last year, I believe. Matrices. Matrices are a multidimensional array. It's an array of an array, pretty much. And so far we've learned about two-dimensional arrays. We've learned about a singular dimensional array, but we're going to learn about 2 dimensions and 3 dimensions. So if we're thinking back, 2 dimensions, there's up, and sideways. 3 dimensions is up, and then there's backwards, and there is sideways, right? I think in space it's radial, non-radial, and I can't remember. Anyway, multidimensional arrays contain more than 1 dimension. So what we did in the last lesson was a singular dimension, so it only goes in one way. We are going to be working with 2-dimensional and 3-dimensional array, multi-dimensional arrays moving forward in this lesson. So you can create 2-dimensional, 3-dimensional, and n-dimensional, whereas n is any natural number. So you could have 1,000 dimensions in your array. That would be giant. But you can, in terms of Java, the max that you can have is 255, because even that is too large for developers to even really worry about. So for our purposes, the max is 255, but you'll never use that. 2-dimensional arrays. I'm just going to move me. Okay. So 2-dimensional arrays can be visualized as a table consisting of rows and columns, and each cell is the table represents an array element. So if you think about it this way, we have our table function, our table here. Okay, this right here is our rows. And then this right here are our columns. Okay, and I'm going to move me again. Okay, I'm going to move myself up here. Okay, so our 2-dimensional arrays here. So we have our rows. That go this way, and we have our columns that go this way. This is a 2-dimensional array. Okay, so when we declare a 2-dimensional array, we have our type array name, and then we have our 2 indexing commands saying that this is our actual array, and this is our actual array, and then we have array name and then type. So this would be like, for example, this could be like int name, right? And then we'd have our row and column. Okay, so this could be your first name, this could be your last name, who knows. But again, just to remember, we can declare it this way. This is the preferred way right here. This format is our preferred way of declaring an array, even in multi-dimension, 2 dimensions. Two-dimensional arrays. This type specifies the type of data in each array element is going to hold. The 2 square brackets indicate the current array variable declaration to a 2-dimensional array. So again, that was this. Okay. This says that it is I'm just going to say 2D. Okay. So here's an example that we have. So suppose we have to write a program to store marks obtained by each student in a class in various subjects. So we are assuming that a student takes 5 subjects and that there are 50 students in the class. We need to create a 2-dimensional array to store the data. So what we have here, we've given this a final modifier. We've labeled this as an integer. We've given it a name. Okay, and we've given this a value. Okay, and we've done that for both. Okay, so we have made our variables. Okay, and then here is our array. And then we have our marks. So we've made a array here. So int marks. So this is the declare. We've declared. And now we're filling that array. In this line right here, marks equals new int. And then we have this array right here. And then we have this array right here. So we're filling in the number of subjects in this array right here, and then we're filling the number of students in this one right here. This would output like this. Our marks are here. Okay. So student ID 1, subject 1, 2, 3, 4, 5, number of subjects. Okay. And then we would have our student ID 0, 1, 2, 3, all the way down to 49. Okay, so that would be student 50. Okay, and then we would have our marks in there as well. Okay, so again, let's look back. Number of subjects, number of students. There we go. This is what would print out with that array. So this is the positions that are in there. So subject 1, student ID 1 would be position 0 and 0. And subject 2 would be 0, 1, 0, 2, 0, 3, 0, 4. Okay? And it will go all the way down to 50. This is our example here. I'm just going to change my pointer options. I'm going to zoom in. We're going to use a 2-dimensional array example here. And so what's happening here is we've made a public class. We have a public static void that we've made. We've made a final int. We've declared this on the same line. Max students 50, max subjects 3. Int marks and new int max students, max subjects. We're going to add to the array ID 0. So for ID 0, ID as long as it's less than max students, it's going to run this for loop, and we're going to increment each time so we're not overwriting the same student and starting at student 1. And then we're going to fill the subject. Okay. For int, we are going to create our variable subject 0. As long as the subject is less than max subject, we're going to increment and run this loop. For marks, we're going to take the ID and the subject, and we're going to create an integer. We're going to use the random method from the math class, and then we're going to multiply it by 100. Okay, so we're adding data into this array here. The next part that we do here is we're going to go through a printing array. We're going to print the array, so we're going to system out print student, and then we're going to format it with a escape key, escape sequence for tab. For in subject 0, subject, as long as it's less than max subject, we're going to increment subject. Print system.out.print tab subject plus tab system out print line, so new line, and then we're going to print the student's ID. So we're going to set it as 4. As long as the ID is less than max students, we're going to increment system out student ID minus 4 plus 1. Right, so that would be 0 plus 1 would be student 1, and then we're going to format it with a tab at the end. And then for int subject 0 subject, as long as it's less than max subjects, we're going to increment, and then we're going to print out the marks ID subject. So again, remember, we're getting our marks filled in with the random variable, so these numbers are all going to be random. We're going to print line so that it prints the next student properly. So if we see this correctly, we're going to zoom out. I'm going to zoom into our table. So here we have our student, subject 0, subject 1, student, subject 1, subject 2, and we have all our random marks. Student 1 is not doing so hot in subject 1. I don't understand how a student can get 90 in a class and then get 2 and 48. But yeah, so you'll see that's how random works. We get a random number put in there. So this would be the format that prints out with our two-dimensional array. Okay. So initializing using array literals. So you can define values of individual array elements in curly braces on the right side of the assignment operator equals during the array declaration. So what this looks like, so we have our int, we have our multi-dimensional array, and subject marks, and then we have our curly braces. And so what's happening here is we're defining values of individual array elements in curly braces on the right side of the operator during the array. So this would go into 1, this would go into 2, this would go into 1, this would go into 2, 1, 2, 1, 2. Okay, so I'll just draw that on there. Okay. Okay, so now n dimensions. So this is a 3-dimensional array. So we worked with two-dimension arrays. Think of those as like tables. It's the easiest way to think of those. 3-dimensionals are a little bit different. So the same concepts that we've covered in for 1- and 2-dimensional arrays apply with n-dimensional arrays as well. For example, if we declare a 3-dimensional array, it would look like this. So we have our type, right? So that could be int. Okay. Then we have 1 dimension, 2 dimension, 3 dimensions. So 1, 2, 3. Again, remember this could be n dimensions. Okay. And then we have our array name and type, and then we have our size. So if we look down here, so we have our type, we have our dimensions. Okay, so this is a 3-dimensional array, and then we've named it named it matrix. New, again, type right there. We have int, and then we have our size of 5, size of 15, and size of 10 elements. So this can contain 5 elements. This can contain 15, and this can contain 10. Okay, so we're going to work with this example, continuing on. So this declaration creates a three-dimensional array right here. Like I said, the first size of the first dimension is 5. Size of the second, so this is the first dimension, this is the second dimension, and then this is the third dimension. Okay, so the size of the second dimension is 15. Size of the third dimension is 10. So the total number of elements for this array is 750. So how I calculated that, as you can see here, is you take the size of the first array, times it by the size of the second array, and then times it by the size of the third array. So the total memory allocations for the entire array is 750 multiplied by the size of the int data type. So because the int data type is 4, the byte allocation will be 3,000 bytes for this particular array. So if I wanted to access the I, J, and K element, you'll need to use the syntax matrix I, J, K. Okay, so again, you're using the indexing value. Okay, so this right here is the index value. Okay. Non-rectangular arrays. So before you start to stress, this is for your own information. I'm not going to make you do this. Java allows you to make non-rectangular arrays, which is when each row of the array may have a different number of columns. I'm never going to ask you to do this. It's just something that you can do in Java, and you might do later on if you continue on in computer science, but I will never ask you to do this. So how this looks like right here, I'm just going to zoom in here. How this looks like right here. So array A is a non-rectangular array. So we have 1, 2, 3, 4, 5 columns in this one right here, only 2 there, 3, and then 4. So how this works is array A has 4 rows. Refers to as each row refers to another single dimensional array. So each of these rows goes into another single dimensional array right here. So like it is like this, but you're actually declaring 4 separate one-dimensional arrays here. So array 0 refers to this singular array. Row 1 refers to this one right here. Row 2 refers to this singular array, and this one is this one-dimensional array here as well. So it is a little bit different way of stacking and storing data, but I will never ask you to do this. So this is for your own information. Again, array summary. An array allows you to use a single variable name to access a large collection of variables. An array list allows you to create an array without having to define its size beforehand. Elements of the array are accessed using the array name, followed by the array array index enclosed in square brackets. Arrays may consist of single or multiple dimensions. And again, I'm going to move me right again so you can see this last one. You can create rectangular as well as non-rectangular arrays in Java. Okay. And that is it for the screencast, and stay tuned for lesson 10.